Welcome back, TTI family. Today we're teaming up with NASAT and one very suspicious-looking abandoned boat that clearly gave up on life a long time ago. Faded, worn, and probably full of character, aka problems, this thing looks like it retired early. But NASAT is about to bring it back, like a comeback story nobody saw coming. The journey begins with the hull, built primarily from wood. Now, wood might sound simple, but it's actually a smart choice. It's naturally buoyant and has a bit of flexibility, which helps it handle the constant stress of water movement. But of course, NASAT doesn't stop there. To strengthen the structure, PVC half-pipes are carefully placed along the interior. These curved pieces act like hidden reinforcements, distributing stress evenly across the hull. The result is less flex, more strength, and a boat that won't panic every time it hits a wave. Then comes the red resin, arguably the most satisfying part to watch. This isn't just for looks, although it does make everything look 10 times more professional. The resin seeps deep into the wood, sealing tiny gaps and pores. This prevents water from sneaking in and causing swelling, rot, or long-term damage. Think of it as giving the boat a waterproof shield. On top of that, it creates the perfect base for fiberglass layers, which will add even more durability. Next, we see thin plywood panels being heat-bent into shape. And no, this isn't guesswork. These curves are carefully planned to form a shallow V hull design. This shape is a perfect balance. It reduces drag in calm water while still cutting smoothly through small waves. In simple terms, efficient, stable, and ready for action. Speaking of fiberglass, large sheets are laid over the resin-coated surface. This woven material, made from fine glass fibers, becomes incredibly strong when combined with resin. NASAT uses biaxial fiberglass, where fibers are angled at 45 degrees. This isn't random. It significantly improves the boat's resistance to twisting forces. So when the boat turns or hits uneven water, it stays stable instead of acting like it's confused about its life choices. Things get even more precise when the propeller shaft system is installed. Drilling through the fiberglass hull requires serious accuracy. One wrong move could weaken the structure, but NASAT handles it like a pro. Every hole is carefully aligned, so the propeller's thrust line matches the hull perfectly. This ensures smooth movement, minimal vibration, and better overall performance. As the build progresses, the upper deck components are assembled and bonded to the hull using epoxy, creating a strong, unified structure. Then comes one of the most nerve-wracking moments, flipping the hull. Inside, foam blocks are added between ribs, improving buoyancy and stiffness. It's like giving the boat a safety net, just in case things ever go wrong. Now things start getting seriously precise, like measure twice, panic once kind of precise. Then things get a bit more technical. Circular recesses are drilled into the wood to allow metal tubes and bolts to pass through, creating a hybrid connection between wood, metal, and fiberglass. The gunwales are carefully positioned flush with the PVC stringers inside the hull, forming a clean, continuous edge. Each section is secured using bolts and washers, spreading the load evenly across the structure. This isn't just for strength. It prevents stress from concentrating in one spot, which could eventually lead to cracks when the boat faces constant wave action. Basically, NASAT is making sure this boat doesn't fall apart the moment it hits a bad day at sea. Next comes the installation of wooden crossbeams inside the hull, using stretched reference strings. Yes, the old-school but super reliable method. The builder ensures perfect symmetry between both sides. These hardwood beams act like ribs, preventing the hull from twisting under stress. At this stage, the builder smartly alternates between mechanical fastening and adhesive bonding. Inside the hull, clamps and temporary brackets hold everything in place while the resin cures. And here's where patience really shows. He repeatedly checks alignment using visual sight lines and tape measures. Because in boat building, being almost straight is basically the same as being completely wrong. Even a few millimeters off can mess with how the boat tracks in water, causing it to drift or handle unevenly. Once the internal bolts are secured, attention shifts to the transom, the rear section that takes the full force of the engine. Extra timber panels are added vertically, forming a thick, laminated block designed to absorb thrust and vibration. After sealing and bolting, the edges are carefully ground down to ensure smooth transitions. No sharp bits, no awkward bumps, nothing that could snag ropes or get in the way later. With the structure solid, the focus shifts to the propulsion system. The gunnel bolts are tightened fully, locking in rigidity and preventing any twisting. Now for the heart of the boat, the propeller shaft system. The craftsman machines the shaft with extreme precision, shaping it to ensure perfect alignment. Once ready, it's inserted into the stern tube, and a stainless steel propeller is mounted and secured. At the transom, large bolts and steel plates are installed through the fiberglass shell, reinforcing the area to handle engine torque. A fiberglass patch is also applied inside, restoring structural continuity and sealing everything watertight. But here's where things go from impressive to downright wild. Instead of using a standard marine engine, NASAT decides to convert a 30-year-old Subaru hybrid engine into an inboard motor. Yes, seriously. The engine is completely disassembled, and every single component is cleaned of decades of grime, carbon buildup, and corrosion. And now comes the part where the engine basically gets a full spa day. Except instead of cucumbers and face masks, it's crankshafts, pistons, and a lot of grease removal. Every major component is taken apart, from the crankshaft and camshafts to pistons, connecting rods, valves, and timing gears. Nothing is spared. The pistons are cleaned and fitted with new rings, with gaps measured so precisely you'd think this was a watchmaker, not a boat builder. Bearings are replaced or reconditioned, and their clearances are checked using plastigage, a method that's oddly satisfying and extremely important. The crankshaft journals are polished until they're smooth enough to spin like they're on vacation, while the cylinder walls are checked for wear. If needed, they're lightly honed to restore that all-important crosshatch pattern, which helps retain oil. Yes, engines also need proper moisturizing. All of this ensures the engine can actually survive its new life, because dropping a half-fixed engine into a boat is basically asking for a very expensive disaster. Here's the thing, this isn't just a rebuild, it's a rescue mission. Over 30 years, the engine has collected carbon deposits, sludge, and all kinds of internal gunk. These aren't just ugly, they block oil flow, mess with heat transfer, and slowly destroy precision. So every passage is thoroughly cleaned, restoring proper lubrication. Because inside an engine, metal parts should never actually touch. they rely on a thin oil film to avoid turning into a grinding disaster. Cleaning also reveals hidden problems. Tiny cracks, uneven wear, or warped components suddenly become visible once the grime is gone. Fixing these now prevents catastrophic failures later, especially important because marine engines live a much harder life than car engines. Out on the water, this thing will run at high power for long stretches, with less cooling and more exposure to moisture. Basically, no room for shortcuts. Now, here's where NASAT goes from skilled to slightly genius and a little crazy. Instead of ditching the original transmission, like most marine conversions, he keeps it. Yep, the same gearbox that once powered a car is now being adapted for a boat. This clever move allows built-in forward and reverse control without needing a separate marine system. Of course, it's not plug and play. A custom adapter plate is machined to connect the engine to the transmission, and alignment has to be absolutely perfect. Even a tiny mismatch could cause vibrations, wear, or failure. Then comes the engine mounting frame, a hybrid support system built from steel and hardwood. Custom steel frames are fabricated, and wooden beams are bolted onto them, combining strength with vibration absorption. The entire setup is then encapsulated in fiberglass, creating a unified, durable base. The flywheel helps smooth things out, acting like a shock absorber for rotational forces. The clutch is also upgraded to handle long periods of load, because unlike a car, a boat doesn't get to rest at traffic lights. Next up is the cooling and intake system, because engines and overheating are not a great combo. It starts with a perforated intake strainer cap, which basically acts like a security guard, keeping debris, weeds, and random ocean junk from entering the system. From there, a cylindrical metal housing is machined on a lathe, carved out of solid steel or aluminum with impressive precision. The internal and external diameters are shaped carefully to ensure everything fits perfectly, because leaks at this stage would be, let's just say, not ideal. To deal with vibration and stress, aka the things that love to ruin boats, the builder comes up with a clever hybrid fix, combining PVC half-pipes with fiberglass reinforcement. These curved PVC supports don't just sit there looking useful. They actually absorb vibration and spread loads evenly across the hull. Think of them as shock absorbers, but for a boat that used to be abandoned and probably had trust issues. Once fabricated, the intake assembly is installed through the hull into a reinforced fiberglass section. Layers of fiberglass and resin are applied around it, sealing everything tight and making sure the hull stays strong, even under water pressure. It's like giving the boat a watertight handshake. Then comes the raw water pump, the unsung hero of marine engines. Mounted on a steel bracket, this pump pulls in seawater and sends it to cool the engine through a heat exchanger. Without it, the engine would overheat faster than your phone in direct sunlight. Meanwhile, the exhaust system starts taking shape. Reinforced hoses are installed to handle both suction and heat without collapsing. The engine's exhaust outlet is connected to a custom-built riser made from welded steel pipes. This riser is carefully angled to guide exhaust gases safely out through the back of the boat. A stainless steel elbow at the end directs everything downward, because nobody wants hot exhaust blasting around inside the hull. Now, attention shifts to the gearbox. Originally built for industrial use, it's taken apart, inspected, and upgraded to handle marine conditions. A new bearing with higher tolerance is installed to deal with continuous thrust from the propeller. Everything is fitted precisely, using press-fit techniques and custom spacers, because again, even tiny misalignments can cause big headaches. Finally, a coupler system with a universal joint connects the engine to the gearbox. This allows slight movement without stressing the components. The gears are cleaned, checked, and adjusted for smooth operation. Now comes the reassembly phase, basically putting the puzzle back together, but this time without leftover mystery pieces. It starts with the gearbox. First, the input shaft and bearing go in, followed by the gear set, and finally, the output assembly. Everything is mounted onto a solid steel bracket made from thick L-shaped plates welded into a rigid frame. Translation: this gearbox isn't going anywhere, even if the boat hits a bad mood wave. A pulley is then carefully prepared with a pilot hole and a keyway slot, locking it firmly onto the shaft so it spins without slipping. Once mounted to the gearbox, a V-belt connects it to the engine pulley, transferring power smoothly. The tension is adjusted just right, not too loose, not too tight. Basically, the Goldilocks zone of belts. For cooling, a copper coil is wrapped around an aluminum housing to form a heat exchanger. Copper's great at pulling heat away, so it helps keep the system from overheating. because nobody wants a boat that doubles as a floating oven. Next, the electrical system is wired up using thick, heavy-duty cables connecting the generator, controller, and ignition system. These wires handle serious current, so everything is tightened securely and insulated properly. No sparks, no surprises, just clean, reliable power. With the structure ready, it's finally time for the moment of truth, the first tolerance test. The engine is fired up, the propeller system starts moving, and everyone collectively holds their breath. Will it shake itself apart? Will it behave? Thankfully, it works. And just like that, confidence level unlocked. With the internals sorted, it's time to beef up the transom. Steel plates are welded onto the stern, reinforcing the area that takes the most punishment from engine thrust and vibration. Think of it as giving the boat a strong backbone before it hits the water. Then comes the deck. Marine-grade plywood panels are measured, cut, and sealed before being laminated with fiberglass and resin. Once cured, the deck is carefully fitted onto the hull, lining up perfectly with the internal structure. Additional fiberglass supports and compartments are added, turning the shell into a complete, functional space. Now for the glow-up. A marine-grade primer is applied first, sealing the surface and helping the paint stick like it means it. Then come multiple layers of durable topcoat, designed to survive sun, saltwater, and general ocean chaos. The result? A finish that's both tough and seriously good-looking. Up top, a control console is installed, complete with gauges and a smooth steering system. Below deck, cables connect the wheel to the rudder, translating every turn into precise movement. And finally, the captain's seat goes in. Yes, the throne is ready. After all that hard work, the boat is lifted onto a trailer, shining like it just got promoted in life. From an abandoned wreck to a fully functional machine, not bad at all. As the boat rolls out of the workshop toward the nearby river, you can almost feel the tension in the air. like everyone's silently thinking, please don't fall apart now. Every bump on the road is a reminder of the hundreds of hours poured into this build. At the ramp, the moment of truth arrives. The boat is gently lowered into the water, and for the first time, the hull meets its natural habitat. It settles in smoothly, no dramatic splashes, no uh-oh moments, just a calm, confident float. Honestly, a great first impression. Before going full speed, the builder keeps things cautious. While the boat stays near the shore, he checks buoyancy and balance. Is it sitting right on the waterline? Is it leaning like it skipped leg day? Thankfully, everything looks perfectly balanced from front to back and side to side. Then comes the real test. The engine is eased forward, and the boat starts moving, smoothly. Steering is tested at different speeds, and everything responds like it should. As the throttle increases, the boat glides effortlessly, cutting through the water with ease. And just like that, it works. No drama, just pure satisfaction.